Hello there, and let's check out section 4.5.4.4 practice test. First thing we have to do for number 1 is to put it in standard form. So I'm going to factor out the pi over 4. Remember, in standard form, the x has to be by itself. So over in this number here, I have to take pi divided by pi over 4. That's the same thing as saying pi times the reciprocal, and the pi's cross out, and I get 4. So that would be standard form for the equation. Remember, your vertical shift is out front, horizontal shift is in here. Amplitude, and we get the period using that number there. Number 2 on our practice test, we're given this thing in standard form, and we're supposed to come up with the different parts. Our vertical shift is this number up here, and we would say that we have a vertical shift of down 2. Our horizontal shift, because it's in a parenthesis, it's the opposite direction, so we're going to go 4 to the right. Our amplitude is the number right there in front of our cosine, 3. Our period for the cosine is 2 pi divided by whatever this number is, in this case 1. And if this is a positive sign, it's not reflected. If it's a negative, it is reflected, so this one is not reflected. Number 3, we're doing the same thing with the tangent function. Since it's already in standard form, we're going to say our vertical shift is 5 up, our horizontal shift is 3 left, our amplitude is 2. Notice that even though it's negative, we never use a negative for amplitude. Our period is pi divided by pi. When it's the tan function, it's pi divided by b, and in this case, our b is pi, so we have to take anything divided by itself is 1. And because this is a negative sign, we're going to say, yes, it is reflected. Number 4. In this case, we are actually going to graph the thing. And since we are doing the sine graph, one period of it, we know that one period would put me out here at 8. Hold it. We have a vertical shift of 3, so let's start there. And we're going to say that is 3. And since we have a horizontal shift of left 4 with a period of 8. So 8 bigger than negative 4 puts me at 4. That's a period of 8 in between there. And since we're doing the sine curve with an amplitude of 2, we'll be going up to 5 and down to 1. And we need to find a couple more points in here to get our 5 points. Half C's there, half C's there, and we know 0 is in the middle there. And since we are reflected, we're going to start down here, we're going to start on here. First, third, and fifth point are on there. Since it's the sine, we would go down first, down 2 because of the amplitude, up 2 on the second one, so my graph would look like that. Number 5. In this case, they give us all the information. We're doing a secant, and we know that the cosine is 1 over, or the secant is 1 over the cosine. We have a horizontal shift of left pi over 2, so we know that we have over here is negative pi over 2. Our period is pi, so pi from negative pi over 2 puts me over here at positive pi over 2. Let's move that just a little bit. We want this distance and this distance to be the same, so I'm going to move it so they're about the same. And we know that we have a amplitude of 3, so I know that my cosine is going to go up 3 and down 3. So I'm going to put a line there, and we have a vertical shift of 1, so let's put my dotted line in. Dotted line right there. Up 3 from there puts me at 4. So I'm going to say this is 4. And because we're going down 3 from 1, we'd be at -2. So now let's see if I can graph my cosine, which we're going to use to get the secant. We are reflected, so my bottom point down here and my bottom point down here, my top point up here, and we're going through at -pi/4 and +pi/4. So we're going through there and we're going through there. So my cosine graph is going to look like that. And anytime it goes through here, we're going to get a vertical asymptote. So I'm going to put a vertical asymptote at -pi/4 and at +pi/4. And from there, we know that our secant is going to be the reciprocal of the cosine. So we're going up there. And down here, we're going to go next to the asymptote on that side and next to the asymptote on that side. I think maybe my asymptote is just a little bit too far over. There we go. And let's take a look at the next one. The cotan. We remember the cotan has a period of pi, but in this case they say 2. So we're going to start with our period of 2, and we know that the cotan has a asymptote at 0 because there's no horizontal or vertical shift, so we're going to have a vertical asymptote there. Our next vertical asymptote is going to be a period further out, so we're going to call this 2. So I'm going to label that 2. And to get some halfsies in there, I got a 1, I got a half, and I got a 3/2. And I know that my cotan is going to have a 0 there. And at my second and fourth point, I'm going to be at the height of the amplitude. So let's call this point up here 4, and this point down here -4. And so I'm going to be up here and down here. And so my graph is going to come in, go through those 3 points, and follow the asymptotes. Cotans go down from left to right. Tans go up from left to right. Here's my cosecant. Cosecant is abbreviated CSC and is the same as 1 over the sine. We know we have no vertical or horizontal shift. Our period is 16, so I'm going to go out here at 16, halfsies at 8, halfsy at 4, and 12. And since we have an amplitude of 2, I'm going to put a 2 there and a -2 there. And since we're graphing the sine first, we know we have a 0 there, a 0 there, a 0 there. If we're reflected, we're going to go down first, up second. And so my graph of my sine is going to look a lot like that. We know that every time the sine goes through 0, we're going to get a vertical asymptote. Let's move that over just a little bit. And a vertical asymptote at 8, and a vertical asymptote at 16. So we have vertical asymptotes there, and our cosecant graph is actually going to be the one in purple. And it's going to start from these and go down following the asymptotes, and going up from that point and following the asymptotes. And the last graph, I think, last graph is number 8 here, and we're going to do tangent. And we have a period of 6. We know that the tangent likes to go through the axes. Right there is where the vertex part is. But since we have a vertical shift over 1, we know that if that's our 1, then we're going to go through there, and then we're going to move up 1. And so our tangent is going to actually be going through that point with our vertical and horizontal shifts. Since our period is 6, we have to do 3 on this side of it and 3 on this side of it. So that's our period. We know that the tan is going to have an asymptote at the first and the 5th point, and we're going to be at the amplitude at the 2nd and the 4th. Halfway between 1 and -2 puts me at -1 is -0.5. Okay. So since my amplitude is 3, and this is the tan, it goes up from left to right, I'm going to be down here at -3 and up here at 3. I know that I'm going to be at this point. I'm going to be at this point above this, so that would make that a 4 right there. My bad. Move that up to 4. And move this one up to -2. With this change, we're going to be there. All right, much better. So then we know that we're going to be going up from left to right, hits that point, and then goes up to the asymptote. That was a little bit tough, but that's how it's going to look. With the phase shift over 1 and up 1, that's how it's going to look. Good luck.